Hi, today this video is on one specific question on 3D trigonometry, a very typical question that have most of the features and parts of what they will usually ask in the exam. So I'm just be going through this question today. Okay, first let's read the question together. The diagram represents a flat plot of land PQRS. PQ is 40, PR is 75, QR is 90, SR is 60, and PQ is 70 degrees. S is due north of R and Q is due east of R. That means SR and RQ is right angle to each other. Okay, let's continue. The area of the land PQRS. Now, this area is not a regular shape that we know of. So we have to do them separately by maybe adding these two triangle together and so PQS P no PQS no there's no PQS PRS triangle PRS area is equal to half AB sine C, half 60 70 times 75 times sine 70 degrees, and this will give you 2114.3 meter square. Now, usually I will approximate to 3SF, but this is not the final answer, so I'm not going to do that. Next part, area of triangle PRQ, or actually you can call it PQR lah. Doesn't matter. Half 75 times 90 times sine. Oops, we don't have this. No, actually we do, because earlier on you read S is due north of R, Q is due east of R. So it's perpendicular. That means it's 90 degrees. 90 degrees minus 70 degrees will give you 20 degrees. Okay. So you'll get 1154.3 meters square. Add them together and you'll get 3268.6. Now, this is the final answer for part 1. We need to approximate to 3SF. So 3270 meters square, because it's not exact. Okay. Part 2, the length of PS. Now, PS is here. It seems that this looks like cosine rule to you. So PS square is equal to 60 square plus 75 square minus 2 times 60 times 75 cosine 70 degrees. And then you press in your calculator, you get 6146.8. And this is still PS square. Of course, we want to find PS, we square root, and we get 78.402. Again, this is the final answer for part 2. So we round off to 78.4 meter. 3SF. I hope you're okay so far. Okay, if got problem, please leave them in the comment below. We can discuss this. Okay, part 3. The angle PSR. Now, after we found PS, we already have another length here, which is 78.402. This allows us to use sine rule to find angle PSR, which is here. So sine angle PSR over the correspond opposite length, which is 75, is equal to sine 70 degrees over 78.402. So sine angle PSR is equal to 75 sine 70 degrees over 78.402. Angle PSR is equal to 64.016, which is 64.0 degrees. Now, this is an angle, is in degree. All right. The approximation you should use is 1 dp. Okay, next question. Part 4, the shortest distance from S to PR. Now, if S is here and this is PR, you will usually be the shortest distance is when your right angle is exactly perpendicular to PR. That's when your shortest distance. Anywhere else, it will not be the shortest. So how to find this? Now, I want you to get this into your head is that whenever you are asked to find the shortest distance, it is good for you to think of area first. Because think of it this way, if this is PR, this is the base, wouldn't this be the height? And from one particular formula of finding area of triangle, half times base times height. And if you already know the area of the triangle, be it any other ways, half AB sine C or any other ways that you are able to find out, you can reverse it to find your height. So, and this is the case today. We already know the area of triangle PSR or PRS, which we found in part 1. So I'm just going to write it down. Area of triangle PRS. We already found in part 1 that is 2114.3. And if I want to use my half base times height formula, it's going to be half times base, which is 75, times the height. Let's call it H. And this will give you 2114.3. That means your H is equal to 2114.3 over half times 75. So H would be 56.381, 56.4 meter, 3SF. And don't leave it as H. The question asks for shortest distance, you give them back shortest distance. At least write out for them. Okay, this is your part 4. Next part, T is the top of a vertical tower at S. Now this is when it becomes 3D. Okay, T is the top of vertical tower, so it's at S. So you will want to visualize that there is a tower that is vertical, and this is T. And the angle of elevation from R. So now we are concerned with here, right? And then this is your angle of elevation. So now, if you can visualize, do not just rely on a visualization. Please draw it out so that you can use this as a guide while you are doing. T, this is S, and this is 10 degrees. And then fill in whatever you know. 60. And what do you want to find? You want to find TS. Now you have all the information. This is just a basic trigonometry. And your relationship is tangent. Tangent 10 degrees will give you TS over 60. Now adjust it a bit. TS is equal to 60 tangent 10 degrees. Press your calculator, you'll get 10.579. Okay, round off to 3SF, 10.6 meter because it's a length. This is 3SF. So now last part, we want to find the greatest angle of elevation. Now the greatest angle of elevation can only occur when this length below your base is the shortest. So that is the shortest distance. It coincides with your shortest distance because they say viewed from PR. So it's this one. Alamak, it's so hard to draw here. Let me erase this part. Okay, I tell you, this is not paper. It's very hard for me to adjust because I cannot adjust the board that's on this. Okay, I try my best. Okay, I hope you can do better. Now, we want this angle. We already have TS. And we already have this shortest distance too, which comes from our first part, which is 56.3 at 1. I'm not going to write it here. I'm just going to draw the triangle in 2D. and I'm going to put it in my triangle. TS we found is 10.579, and my shortest distance is 56.381, and I want this angle. So again, your basic trigo. So tangent theta is equal to 10.579 over 56.381. So your angle theta is 10.627. 1 dp, so 10.6 degrees. Okay, I hope this helps you in some one way or another, and I'll see you next time.